So in a high-speed car chase, the felon is driving at 12 meters per second for 7 minutes. He pulls on his emergency brake and does a complete 180. He then proceeds to travel at 18 meters per second west for 15 minutes before arriving at his destination. Calculate the average speed and then calculate the average velocity. So we're dealing with something a little bit more complex now. Keep in mind that you are, there's some conversions that need to happen here. The minutes need to be in seconds. Okay? All right, so let's do part A first. Calculating the average speed. So when we're finding average speed, V average is equal to D total divided by T total. So, in order to figure this out though, what do I have to do? Like, what's going on here?
You gotta take V1, like do your slope thing.
I have to do a slope thing?
Well, like you have to take,
Okay. So this is kind of like the first situation that happens, right? You agree? Like
Yeah.
the first thing. So let's say this is number 1. I'm still not aligned, but okay, that's number 1. And then this is number 2, okay? So for both 1 and 2, we're given velocity and time, speed and time, speed and time. But we need to find distance, right? So we're going to use that information to find our distance first for each times, and then we can find our average speed. Because we want to look at both scenarios and find overall what's the average speed for both. But we're not given distance, so we got to do a little bit of legwork to figure that out first, okay? So what we'll do is we'll find distance for number 1 and number 2, and then we will go back to this question. So to find D total, what I'm going to do is I have to solve for number 1 and number 2 before I can even use this equation. See that? So this information I'm going to find out here and here. So for number 1, my information is that I'm going to call it V1 was 12 meters per second, and my T1 was 7 minutes. I need to convert that to seconds. So I'm going to times by a fraction. It has minutes on the bottom and seconds on the top. 60 seconds for every 1 minute. So it's 420 seconds. So now I can find my D1 from this information. So my V1 equals D1 over T1. I'm going to rearrange to solve for D1. So then my D1 is equal to 12 meters per second times by 420 seconds. Which is 5,040 meters. Now really, I maybe should have made, well no, I'm not doing speed, I'm just doing speed, so I don't have to have positive or negative. Yeah, that's right. Okay, so that's when he was driving east. See? So that's how far he drove when he went east. I'm just going to make this a different color. So number 2. So this is when he turned around and went west now. So we need to find how much distance he went when he went west. So my second velocity is 18 meters per second. And the time, T2, was 15 minutes. I need to convert that into seconds. So I have minutes on the bottom, seconds on the top. So I get 900 seconds. So now I can find my D2. So D2 is equal to V2 times by T2. So 18 meters per second multiplied by 900 seconds. One 16200 meters. Okay, so now I have my two distances.
So then we add them together.
Now we can add them together and put it into that formula. So now, see, we just found our D total, so we add those two together to put it into that formula. So how about I actually do it just up? Okay. So now I can say this is 5040 meters plus 16200 meters, all divided by both of my times put together in seconds. So 420 seconds plus 900 seconds. Now, when you put this into your calculator, do it exactly as it's written. Write it in brackets. So if you want to do the top in brackets, divide it by the bottom in brackets.
Isn't this 16,200 later?
But this is distance, not displacement. So we don't, when we do the next question, we will have to put it into a, yeah. Do you see the difference though? Yeah. I know, I caught myself too. I was thinking, oh, do we have to put it? So, we should get about, what, 16.09 repeating meters per second. Per second. So in sig digs then, ooh, but you caught something, Ty. This initially shouldn't have had an arrow over top of it because we are finding average speed. So my V average then, where am I? 16, right? It's a sig digs. And no direction because it is speed. Speed is a scalar quantity, so no direction is needed. Good? Let's do average velocity now. So now, we're going to do part B, is average velocity. Now we need an arrow over top. So a lot of the legwork has already been done for this question, but what is going to be different? What's the only calculation that has to be different? The displacement. What needs to be different?
It's going to be a smaller number.
It will be a smaller number, and because I need to put that west into a negative and have the east as a positive. So that's the only thing I'm going to change. So I'm still going to use the data that I was given here. So I'm going to say my D1 is positive 5040 and D with an arrow because it was going east. And D arrow 2 is negative 16200 meters because it was going west. My T is still the same, T1, because time is always scalar. We will not talk about time being anything but until physics 30. And then time gets weird. Okay, 900 seconds. So now we can put this information into our formula. So So a little bit less work than the first time, because we can use what was already done. So positive 5040 meters plus a negative. Divided by our times put together. So, what do we get?
I got 8.45.
Pardon me?
I got 8.45.
8.45 repeating.
Should it be negative?
It should.
Yeah, negative.
Okay,
Yeah.
very important, yes.
Negative 8.45.
Good, okay. So negative 8.45 repeating meters per second. So we can't, it's not appropriate to leave that as is. We need to put it into 2 sig digs. And at the same time, I'm going to translate the negative into a direction. West, yes. The negative we chose for this question represents the direction west. You could really choose it to be anything you wanted, but we just said, okay, it's west. So 8.5 meters per second, comma, west.